Greetings students. In this lecture, we'll talk about the methods for evaluating the limit of a function. So in general, we have four basic methods for evaluating the limit of a function that are the rationalization method, the factorization method, the substitution method, and the rule of D-L-Optal. Now, keep one thing in mind, that all of these methods are only used when we get an indeterminate form. In most cases, we would have a 0 by 0 form. So let's just get into the detail of each of the methods individually. So let's start with the rationalization method. In the rationalization method, we rationalize the factor containing the square root. As you can see in the example given on your screen, we have limit x approaches to 3 under root x plus 1 minus 2 over x minus 3. Now, if we put the limit in the example given on your screen, we would have 3 plus 1 minus 2 over 3 minus 3, and that would give us 0 by 0 form. So we'll get an indeterminate form. So whenever we are given with these sort of questions, we have to use the rationalization method. Now let's solve this question using the rationalization technique. Now the rationalization technique says that we have to rationalize the given question. So what we have to do it, we have to multiply it with under root x plus 1 plus 2 in the numerator and under root x plus 1 plus 2 in the denominator 2. So we would be left with, as we know, as per the property of algebra, we'll have x plus 1 whole square minus 2 whole square, and in the denominator we would have x minus 3 under root x plus 1 plus 2. Limit x approaches to 3, we would have x plus 1 minus 4 over x minus 3 under root x plus 1 plus 2. Simplifying it further, we would have x minus 3 over x minus 3 under root x plus 1 plus 2. Now if you see, in the numerator we have x minus 3 and in the denominator we have x minus 3, 2. So they will cancel each other out and we will be left with limit x approaches to 3, 1 over under root x plus 1 plus 2, and that would give us 1 over 2 plus 2, and we'll have our final answer as 1 over 4. So now you see that in the question we had a 0 over 0 indeterminate form by directly putting the value of the limit, that is 3. So what we did is we rationalized our given question and we got our final answer, that is the 1 over 4. And this concludes our first method, that is the rationalization method. Now let's move on to the second method, that is the factorization method. In the factorization method, we factorize the numerator and the denominator, of course. So again, let us try to understand it with the help of an example. We have an example that says limit x approaches to 4, 4 minus x over x square minus 16. Now again, if we put the limit directly, we would have 4 minus 4 over 16 minus 16, that would give us 0 over 0 indeterminate form. So we have to do something about it. So what we'll do is, we'll factorize our question and that would give us our final answer. So limit x approaches to 4, we take minus common and we would have x minus 4. In the denominator, we'll open it up by the formula a square minus b square is equal to a plus b, a minus b, and that would give us x plus 4 and x minus 4 respectively. Now you can see in the numerator we have x minus 4, in the denominator we have x minus 4, so they would cancel each other out and we're left with x approaches to 4 minus 1 over x plus 4, and we would have 1 over 8 as our final answer. So this basically is the factorization method. We factorize our question to get our final answer, that in this case was -1 over 8. Now moving on to the next method, which is the substitution method. In this method, we try out different forms of substitutions depending upon the form of the given function. So it will depend on the question basically that which substitution we are to use. Let us try to understand with the help of an example. We have an example that says limit x approaches to 25, 5 minus under root x over x minus 25. Now again, by directly putting the limit, we would be left with 5 minus 5 over 25 minus 25, and that would give us 0 over 0. So we do not want that, so we'll do something about it. So what we'll do is, we'll use this substitution. Now in this question, the problem that is being created is due to this under root x. So we'll suppose or let under root x is equal to u, so x would be equal to u squared. Now you can see that the limit we have is in x form and we have to transform it into the u2. So we have a limit x approaches to 25. So when x approaches to 25, as u is equal to under root of x, so u would approach to 5. So we'll have our question reconstructed. That would give us limit u approaches to 5, 5 minus u over u square minus 25. Now simplifying it further, we would have limit u approaches to 5, taking minus common, we would have u minus 5, in the denominator we would have u plus 5, u minus 5. Now note, here we are using the same factorization method that we studied in the previous slide. As you can see, by putting the value of 5 here, we have 0 over 0 form. So we are using the factorization method here too. So u minus 5 cancels out with u minus 5 and we would be left with minus 1 over 10 as our final answer. So here you can see that in this question we use the substitution method and the factorization method together to solve our given question. So it depends basically on the question that which technique you have to use and why. Now moving on to the last method, that is the rule of the L'Hopital. Now the L'Hopital rule is the most easiest and the most important method for the evaluation of a limit. We take the derivative of the numerator and the denominator. Now here you can see in the example that we have limit x approaches to 0 sine x over x. Now if we put in the limit, we would have 0 over 0 form. So we have to do something about it. So we'll use the rule of the L'Hopital. We'll take the derivative in the numerator and we'll take the derivative in the denominator. So let's see what happens when we take the derivative in the numerator and take the derivative in the denominator. We know that the derivative of sine x is cos x, while the derivative of x is 1. So limit x approaches to 0 cos x. We know that cos 0 is equal to 1. So we got our answer as 1. This basically is the rule of the L'Hopital, that we take the derivative of the numerator and the denominator. Well, that sums up our topic